All right, welcome back. Today we're going to continue working on the in-class Unity tutorials, and we're going to start by where we're going to get to tonight is we're going to get to the robot in this situation actually being attacking the player, and so we're going to add to its state machine an attack ability. But we don't want to just have it where the robot automatically is going to perfectly shoot at the player every time. There are times and situations for that. If you want to import or include like a heat-seeking missile type attack, then that's obviously one thing. But just like a regular weapon attack, there should be a chance that they're going to miss. And so we're going to build that in first. And then we're going to begin exploring or playing with the state machine to add the robot's ability to shoot. And then we'll actually add in our ability to shoot the robot, exploring collisions and different type of collisions and things like that for this video. So let's dive into it. We're going to get into my project. We're going to add a new script. So we'll go into our scripts folder, and we're going to create a new mono behavior script, and let's just go ahead and call this. We're going to call this enemy targeting. Since it's going to be the enemy that's targeting the player rather than player targeting. And so we'll do that. I did get a request for trying to make the font bigger on this. Let me see if I can figure that out so it's a little easier for you all to read. Hold on just a second. Alright, that should be hopefully a lot better and easier to see. It's at least easier for me to see, so hopefully it's going to be easier to see in the video. Alright, so in this, we're going to just add system collection in here. Collections. Okay, so what we're going to end up doing is, let me go back, I'll just save this. In our player, actually I can just go ahead and place this. Let's zoom in our player, right? We've got our gun attached. Actually lift this guy up for a moment. Go to our floor. I moved everything around so it's a little easier. Bake the floor again. Got too much here. That's fine. We'll just leave it as it is. Not going to affect anything at this point. Alright. So what we're going to end up doing is we're going to place an empty game object onto our player. So we got our player, we're going to add an empty game object, and we're going to pull this out. Let's just call it 1, move it X to 1. And we're going to call this enemy target. So that we can see what's happening, what I'm going to actually end up doing for a moment is under this enemy target, we're going to go ahead, we'll right click, we'll add a 3D object, a sphere, and we'll just shrink this down to like 0.2. So it's just a little small sphere, and maybe we'll actually set the color of it so it's a little easier to see. To, I believe it's the active scanner that's red. It is. So we'll just make that red just so it's a little easier to see. Okay. And so what it's going to do is this sphere is going to spin around the player, And this is what's going to be the enemy is going to target. And so we'll remove the sphere so there's nothing that its shots can collide with. But when it's shooting, if it's shooting and it, as we see here, if I was from the perspective of the enemy and I was shooting towards this target, that shot would miss the player, right? But if that was here, right, now if it's targeting this, that shot's going to go through and it's actually going to hit the player. Here, maybe not, right? If it's over there, it's not going to hit it. So it just makes it a chance to that, and also, you know, it makes it so the player maybe isn't as easy to always like dodge the shot, right? You know that the shot's gonna be fired at a certain time, but you're not exactly sure where it's gonna go. So we're gonna do that. We're gonna spinning that around, and so we're gonna do that with the code. We're going to want to get. We're gonna set a serialized field. It'll be a private game object, and we're going to call this target rotation point because we need this thing to rotate around a specific point, and then we'll also do one of target so that we can put that the empty game object in there. And then what we're going to also do, rather than just going round and round and round, we're going to also have it rotate kind of up and down, oscillate like a sine wave to a degree around the player. So we're going to just do a private boolean is target going up. And we're going to start out with it being true. So we're going to start with the target going up higher. And then it will eventually drop down, and so that'll cause that wave format. Also, the other thing, we just don't want it to be, or I don't want it to be consistent, right? I want to be able for this to feel kind of all over the place, right? You're in an actual battle, and you know we don't have perfect aim, and so I'm gonna add two private floats that we will describe what they are here. So we're going to set up variables for them: random rotation speed in the y direction and random rotation speed in the x. So one's going up and down, one's going to be going around, and then we can change that as we go along. We don't need that one. Okay, so we're going to leave on start because we want to initially set up those rotation speeds. So what we'll do here before we fill in the start, we're going to do a private void because we're not returning anything. We could set this up as a returning. Either is fine. I'm just going to set it up this way. We're going to call it set rotation speed y. And so what we're going to do, we're going to set our random rotation speed y is going to equal a random, so this is going to give us a random, it accesses the random, basically math functions. So we're going to do random dot range. And what random range does for us is we get to set a minimum value. So a minimum speed is going to be 0.5, and our maximum speed is going to be 3. You can dial this into how you want it to be, but that's what that is going to be in this. And then we want it to be able to change, right? We don't want it to constantly be at just at that same one speed. So we're going to create a float that's just going to be a part of this function. So we can declare it here, and we'll call random delay for the y, and we're going to also do random range. So we want this to be randomized, and we're going to say let's do you can be for 3.5 seconds to 6 seconds. But let's go ahead and for giggles, I guess, we're gonna modify this by what the random rotation speed is gonna be. So if it randomly has a delay of 3.5 seconds, but the speed is 3, it's going to only be that for a short period of time, right? Versus if the speed is a half a meter and the time is 6, right? It's going to be go slowly for a longer period of time. And so we're gonna real quick. We'll get to this. We're going to treat this through a coroutine. So we're going to set up the IE enumerator for that coroutine first, and we'll call it Y rotation reset timer. And we're going to pass into this the delay, which I'll show you in a minute what that's going to be. And then we're going to go ahead and start this coroutine. So start. So back up in our set rotation speed Y, we're going to start the coroutine we just created. So start coroutine Y rotation timer, and we're going to pass in that random delay time, right? We've set up this random delay. That's the time that we're going to wait. So now we can yield here, return, wait for seconds, delay. So we've passed in a float. This requires a float. Return new. So yield, return new, wait for seconds, delay. So it's going to wait for that. Once that delay time has happened, we're going to go back and set rotation speed Y. So it's just going to loop constantly between these two as it is constantly circling the player. And so now we can go ahead in our start, set rotation speed Y. Now it's going to allow us to get that initial rotation speed. And then let's go ahead, and that's going to be the rotation speed around the player. So let's get the quote, the oscillation speed, I guess it is. I'm just going to continue to call it a rotation speed, but it really is more like an oscillation speed. So we can do a private void set rotation speed X. And it's going to look very similar to what we just did. So random rotation speed X is going to equal a random range. Right, we want to pick a number within a range of numbers. For this one, we're going to change that speed up a little bit more. We're going to make it a little bit wider, from 1/4 to 4. And we're going to do the same thing as we did below. We're going to create another float just for this. Whoa. For a random delay. Random delay X. And we'll do the same thing that we did, but we'll modify it again. Random range. We'll have it be here for longer. So we're going to be there for minimum of 4 seconds. So 4 1/4 to 8 seconds. Once again, minusing what our random rotation speed X is going to be. And we're going to start one more coroutine, so we'll set that up. Enumerator, X rotation reset timer. We're going to do the same thing as we did, call float delay. Come on, there we go. And we're going to yield just like we did before. It knows what we're doing. We're going to yield for that delay, and then we're going to set the rotation speed again. So we can come back up to setting the rotation speed and call our coroutine, start coroutine, x rotation and pass in that random delay x. So this is going to now randomly set the speed in which it's circling around the player and the speed at which it's oscillating up and down. But we need to from the start, so we're going to now also set rotation speed x. We need to run both of these at the start because that's going to get that moving right at the beginning. Okay, so we have this going, we have this moving, it's trekking around. So where it's doing all the major lifting is in the update, right? This is just setting our speeds and the timer that we're putting those changes on. And so now we actually need to move it. So what we're going to do is we're going to start a vector 3 because it's moving in three dimensions, and we'll call this temp vector 3, and we'll say it's new vector 3, and we're going to have the target rotation point dot transform dot position dot x. Oops, that fell off the screen. And bring that over a little bit. So vector 3 target rotation point. This is where it's looking at, right? This we need to know. And so we'll do that, and then we're going to get the, so what we need to do, and what this is all leading towards, is we're creating a where the player is looking, or not the player, where the target is facing, because what we're going to use is a look at to have it spin around. It's going to constantly be looking at this one spot, which is going to be the center of the player. And so, but because if we leave it a single spot, as it goes up or down, it's going to then rotate its looking up and down. So we need to make sure that we are only looking directly straight ahead in that facing of it. So we're going to then, for that, to make sure as it goes up and down that it stays in that one spot, we're setting up this temporary vector. It's going to have the x and z positioning of the rotation point, but we need to set our target transform dot position dot y. So this is going to set our height. This is going to make sure that that temporary vector is going to be exactly in line with the height of the target that's spinning around. And so then we'll finish this off. Target rotation point dot transform dot position dot z. Let me see if I can get all this on one screen so you can see it all. There we go. That will make it easier for y'all to read. Okay, so now with that, we're setting up this temporary vector, and so now our target can transform dot look at. This way it's facing that whatever we tell it to look at. In this case, we're going to have it look at that temporary vector we started. So that way it's always looking straight across, no matter where it is, up or down from the player. And then we handle its movement. We're going to target, oops, that's not target, target dot transform dot translate, it's capital T, translate, and we're going to have it translate, we're going to have it move to the right, so vector 3 dot right, so it's moving to the right. We're going to multiply that by our random rotation speed in the x, right? This is moving around. And then we'll multiply this also by time dot delta time. That way it's moving smoothly. around the player constantly, and at whatever that random rotation speed is. So this will change how fast it's rotating constantly. Okay, so we've got that in. Now, let's make this a little bit wider so I can feel better and see my brackets. Okay, so we've got that going. Now we need to handle it going up and down. So if is target going up, this is what we're going to check. So a reminder for booleans, we can just pause the where we're going in a minute. This here, if is target going up, so it's checking to see is this boolean true. This only works for booleans. It's the equivalent of equals true, right? But we can shorthand it with just this. If we wanted to check and see if it was false, right, we could do this, or we can use an exclamation point, which basically means false or not. Is this not happening, right? So we can check that Boolean in that way, shorthand without typing it all in, but we're going to go for the true version. So if it's going up, right, which we, if you remember, scroll back up, we originally set to true. So we are going to start out in this branch in our update. So if it's going up, we're going to say that target transform dot translate. So the movement is going to go vector 3 dot up. So it's going up times the random rotation speed x times time dot delta time. And then we're going to check and see how high up it is, right? We don't want this to go so far above the player that it doesn't really matter, right? We still want to feel like it's close. So we're going to add in a float variable here. We're going to call it target y distance. So what is the distance of the target in its height? And so we'll figure that out by getting the target transform dot position dot y and subtract that from the target rotation point transform. I didn't get wide enough. That's all right. Let's just bring it over. Y. Right, so all we're checking is the height. And so with that, we now have, this is going to give us a number, right? So if we're going up, it's going to be a positive number. So we can check and say, if now you've already moved, so now that you've moved, is the target y distance greater than 2? Is this now 2 meters above that target rotation point, which is going to be in the center of our player? So if this is true, we're going to set is target going up to false. Because at this point, it's gone up as much as it can go up. We don't need it to go up any higher. Now we need it to go back down. So we handle that now through an else on here. So our else is the equivalent now of saying, is the target going up false? And so if that's the case, our target, we're going to move it to the translate like we've been doing so far. We can do we're going to still do a vector 3 dot up, but we're going to multiply it by the inverse of our rotation speed. So this is going to make it go down. So negative random rotation speed y and time is our time.delta time. So if it's not going up, it means it's going down, and so we can still use up, but we just multiply it by a negative version of our speed number, and that will force it to go down. So we'll do that, and then we're going to do just like we had done before. We're going to also get a target y distance. Target y distance, if I can type this in correctly, and it will equal a target, same exact thing, target transform position.y minus target rotation point dot transform dot position dot y, right? So it's doing the same calculation, whether it's going up or down. It is calculating the distance, but now, right, we're going to start seeing a negative. So that target rotation point is technically our 0 point. And so with that, now we can say, okay, now you're going down. Are you, if target y distance is less than negative 2f, right? Because that rotation point is our negative, or is our 0 point, so we're dropping below. If that is below it by 2 meters, we can now do is target going up and set it to true. So that's now going to have that oscillation happen. Okay, that's a lot of code without testing anything. So let us test this. Let's go ahead and make sure we save. And we're going to go drag this over a little bit so I don't lose it. Come back here. We're going to attach this to the enemy target. So drag our script, enemy targeting onto the enemy target. Our target is the enemy target, so we could add this as self. We're just going to drag it in here just in case we wanted to put this somewhere else. We can have it set up there. And our target rotation point is going to be the player. Right, so this is going to forever. So if we click on our player, if you see our Y, our X, and our Z, right, that is placed right in the center of our player. And no matter if we're jumping, moving, whatever, that is forever staying in that position. And so what we'll do is, we've got that on there. Once again, the sphere is only on here so we can visualize it. So we'll save, we'll hit play and cross our fingers that ball is going to start spinning all around, up and down, over. It's going now really slowly around. And then, then we get a nice big speed burst, changing its velocity up and down. And so now, if this is what the enemy, in this case, our robot, that is working here, well, he's not working because he's trapped, but that's okay. We'll fix that again in a minute. Is going to be shooting at. Now he's not going to guarantee always to hit the player. All right, so we're going to stop. Oh, then if we so if I'm moving, right, that thing is always moving with me. No matter what I do, it's just circling around me because it's always looking to that one point. Okay. Perfect. We've got that, so I'm going to actually turn the sphere. I'll leave it on for now, but what I'm going to do to make it so that it definitely can't be hit, I'm just going to click off the sphere collider on the sphere, so anything that would come and hit it, big air quotes, would not be able to do so. All right, let's go over and rebake that floor, which should, there we go, removes that. Now it should actually move around. There we go. Okay. So from here, we now have that going around. Let's go ahead and make the robot be able to shoot. So what we need to do is we need to go into a state machine. And we could do this in multiple different ways, right? So we've got our, close a few of these so I don't get confused. Right, so we have our robot states, right? So just a reminder on this, every time we create a new state, it needs to be able to check transitions, it needs to be able to have actions, and then it also has to have an on state enter, on state exit, right? So if we go to our robot working one, we just double check, we have that on state enter, check transitions, actions, on state exit. Same thing with the sleeping, right? We have all these. We could add an attack in multiple different spots. What I'm going to set this up as is if the robot is working and the player gets within, let's say, 5 meters of it, it is going to move from the working state to the attack state. So let's go ahead and set that up. What we're going to do is we're going to create a new script. We're going to do, that's perfectly fine. We'll just set it up that way. Create script, we can modify it, robot attacking. So we have our new scripts. We'll go ahead and open it up. We're not using the, as we've set up in the working, we're not using the mono behavior. We're going to actually use robot state. So robot state. We need to, as we've done before, this is where copy and pasting is great, right? So we're going to copy the 2 usings and paste that into our here. Because we've set this up as part of robot state, robot attacking doesn't work right now because we don't have any of our requirements. So what we're going to do, once again, we're going to just cheat a little bit. We're going to copy everything from sleeping in here, and we're going to replace our start and update with that, and we're going to change this to robots attacking, and with that we are quote good to go. We're going to let's go ahead and leave this code here. We're going to, let's save this. We're going to come back to our robot state controller. This is our main part, right? So if you remember, this is where all the stuff under the hood is. This is our update, which is telling us every frame, check transactions or transitions, and then run our actions, and then how do we change our states, and setting our destinations. All right, and so we have currently a material red and green. I'm going to add in a blue. And so what we with that, so we now have a public material blue. And so we need to go back into our Unity. We'll go into our materials. I'm going to copy the, doesn't matter, one of either the active or passive scanners. I'm going to get Control D to duplicate it, and we're going to call this attack scanner. And then we'll set the color to, bring my color wheel over so you can see what I'm doing. Let's just do a nice blue. And then we need to make sure we put this in, robot. Now we're just going to drag our attack scanner to blue. Maybe. There we go. Okay. We can save that. So now we have blue. So now we have an ability to know if we're actually in that mode. So we're going to go back to our robot attacking script, and we're going to change this to blue. So when we enter the attacking state, it's going to be blue. Okay. So we need to, for the attacking state to happen, we need to go ahead and, how do we get here, right? We need to be able to transition into here. So what is it that's going to cause us to transition? And like I said, when you're working, when the robot's working, if the player gets within 5 feet or 5 meters of it, it's going to go on the attack. And so let's go into robot working so we can set this up. So on check transitions, we're going to, we have in here, if you remember, we have in here our system for checking to see if the player is close enough for then the robot to attack, or not attack, go to sleep, right? So we have this raycast that's going out. So we need to make sure that the player is happening, right? So in this case, if it doesn't see the player, right? If whatever it's colliding with is not player, it's going to go to sleep, right? It cannot see the player, take a nap. So what we can do in here is we're going to add another transition in here. So if kit.collider.gameObject.name equals now player, right? And let's verify if we have it. I cannot remember if we've got a thing in here. Yep, we've got game object the player. So then, and if it's hitting something called player, and rsc.player I wanted to put it there, but we're not. We could, but have to add other code up here. So we're going to just add it within here. So if it hits player, then we're going to get a float. We're going to just call it dist as temporary, right? And that is equal to vector3 dot distance and we're going to go RSC transform position and RSC dot player transform position, right? So this is how we're going to get the distance out of it from the robot to the player. How far is it? And so if distance is less than 5 meters, then we're going to go RSC, set state, new robot attacking RSC, right? So this is going to move us into our attacking state, right? So now we have gotten here. All right. So if we're attacking, so now we've got how we transition to attacking, right? And so on exit does nothing currently. Robot attacking is going to need a way out. This was all copied over, so let's say we're just going to reuse some of this. We're going to once again get the distance because we copied this over. Might as well use it. It's perfectly good to reuse your code however you can. And so what we're going to do is we're going to get the distance once again from the robot to the player. If that distance, we're going to change it. If the distance is now greater than, we're going to say 15 meters. We're going to go back to working. So if the player, so the robot starts shooting at the player goes, oh shit, the robot's attacking me, runs away, then the robot's going to get back to work. And so that is how we're going to transition out of attacking, and it will always transition. Currently, we will always transition from attacking to working. All right, and so the other thing that we're going to do is when we are, like when we go to sleeping, we're going to set this up as I had talked about last time we set this up, right? We're going to, when it's attacking, it's not going to move, right? It's just going to stand there and stand its ground. And so we're going to copy this code telling the nav mesh agent, which is the robot, that it has stopped. We're setting is stopped to true. So we're going to copy that and bring that over to our robot attacking. But we're going to add this now to the start of our on state enter, right? We had set up on sleeping that this is just the action it does every time, but we didn't need to, right? Is stop setting to true is not getting set to false anytime in here to need to be reset. So we're handling it as you would expect to handle it now. And this one we're setting is stop to true. And then make sure that robot working is set, right? So then as we would come out of attack and transition into working, that on state enter, right, we turn the movement back on. We said is stop is no longer true, is false. So now we have that. So we can delete this action. Okay. And so what we're going to do is the robot is going to be shooting at the target. Go back out. It's going to be shooting towards our enemy target, right? As it spins around the player. And so because of that, we're going to need to get a reference for that. So in our, where did it go? There we go. Forgot to bring it over so I can see it. In our robot state controller, remember everything that we're gathering and doing in our robot's state controller or in our state machine goes through the main robot state controller, right? That's our main passageway to everything else in our environment. And so we're going to add a game object that we're targeting, and we'll call this, we'll just call this enemy target. So this is going to give us access to this. So before we forget, let's go ahead and go back out to our Unity, click on our robot, scroll down, and now we have the enemy target. Let's go ahead and bring that now in so that we have that there. We can hit save and come back to our code. Okay, we need to put a few more things in here. We need to create a, let's see, we've got what do we want to do? So let's go ahead and let's just make use of what we set up. Okay, we need to also create a public transform. We're going to do this separately from our other transforms because this is kind of a different one. While I do like to put similar things in the same line, I also will break them up based on what they are, so it makes it sometimes a little easier to read. So in this case, it's not a destination. We're going to get bullet, or we'll call it, I'm just going to call it attack launch position. So it's not really sure what we want it to be attacking. So we need a call to that. And then let's set that up first. We're going to, on our robot, we'll zoom in here, and we're going to attach this to our scanner. And let's guess. It's been a hot minute. We're going to add a create an empty. Remember, we're going to want to give it enough space. I think this is right. Hold on, let's double check. Where's my player gun? I believe it's off of. No, it's off of the Z. I guess either right or wrong, and usually I guess wrong. So we're going to actually pull this out this way, and we'll call this, let's call it laser launcher. Why not? And so we've got that. Remember to pull it far enough away so that it's not going to target or hit the robot as it spawns and then launches. So we've got that. What we're going to do as well is we're going to, let's see, let's open up our player controller script. So once again, we're going to reuse some code. So it's always easiest to just go ahead and reuse the code that you've written. And so we're going to reuse the shooter. So we're going to use the same bullets. But we're going to have a little bit of fun with them as we do it. And so what we're going to do, we'll make a few changes, should work, is we're going to take all of this. Actually, we need to, let's grab first our we have, hold on, let me look at this. Okay, that's right. We want access to our game controller because that is where our bullet pool is. We're going to use the bullet pool like we did before. So what we can just do to make life easy, we're going to steal this and add it to our state controller. So on access to our game controller, we're going to steal our game controller setup so that we have that. Add that to our state controller and our start. And then we're going to leave that, but we're going to go ahead and grab the rest of this. We're going to put this in our state controller. Because, and the reason for this, right, we could, we're going to call public. This will be a void. We're not returning anything. We're going to call it attack. We're going to call this shoot laser at player. And we'll just paste in this for now. We'll get there in a minute. I'll make these changes in a second. What we could put all this code into our robot attacking script in our action. The trick with that is that locks it mostly into this state. And maybe we want to be able to attack from a different state, or we want to be able to get access to it. So we're going to build that in the state controller. So we have access to this from everywhere. And so we're going to set up we are going to go ahead and getting it from the bullet pool. All right, let's go ahead, bullet. I think we can just, instead of setting it up as a serialized field, I think we're going to just go ahead and set it up as the game object. And that will just get covered through that because it's getting filled in through that. We don't need to set it. And we're not using the bullet launch position, right? We're going to use our attack launch position. So we can just grab that variable and we're just going to replace these. We don't need our data controller. We're not using that at the moment. We're not going to use our shots counter because we don't need that. We will want to also put in a shooting pause coroutine because we want it not to be a machine gun, unless that's what you're looking for. And even with that, you're going to want some form of a little bit of pause. So we'll add that in a minute. So what we'll do is let's go ahead and come back up and we're going to add a Boolean. Actually, I need to set this to public. My bad. Public the game controller just because we can access it from somewhere else. And a public Boolean bool okay to shoot. We're going to start it off as true because there's no reason for it to not shoot. And so what we'll do, we've set it to true. We're going to be able to set it to false. What we're going to do is we're going to actually right in here, okay to shoot is now equal to false because we just shot, right? With all the code here, we've gone ahead and shot, or we've fired our shot. And so what we'll do here is our IE numerator, our coroutine. We'll call it shooting pause to make sure that it works. And yield return new, wait 4 seconds. Let's say the robot can shoot once every 2 seconds. And then we'll say okay to shoot is now true. Why are you having an issue? Apparently I need to use the other one. All right, so make sure that if you did like I did and added in this one, that's not the one you're using. You're using just the straight up one. All right, and so what we've got here is a shooting pause. It's going to shoot. It is going to match everything there, and it's going to go flying. All right, we'll save that. So now what we can do is we can go back to our robot attacking. And so now in the action, we can call back to if RSC dot okay to shoot, right? And remember, since it's a Boolean, we don't need to type in the equals true or false. So this is set. So is okay to shoot true? Great. If that is the case, right, we're in the attack phase, then we're going to RSC dot shoot laser at the player. We're going to run that script. Okay, so if we do that, what are we missing, right? It's going to just shoot based on how it was. And so what we're actually going to want to do is at the start of our action, we are going to rotate. So RSC scanner dot transform dot look at I already knew RSC player transform position. So what this is going to do is look at the player, right? Actually, no, we don't want this. Hopefully some of you are like, you don't want that. That's not right. And for those who are like, yeah, you want the player. We don't want the player. We normally, that would make it so that we are always accurate. We want it to instead look at the enemy target. Now, this is going to, what we would really want to do, and this is going to get into more complicated things than we really need to get into. Okay, let's do it. We want to have it actually look at the player, right? Because it is shooting at the player. Even if it's going to miss, it's trying to shoot at the player. So the scanner is going to look at the player. And then what we can do is after that looks at the player, we can have the RSC attack launch position transform, look at RSC, enemy, target, transform position. So the scanner is looking at the player. So it looks like it's targeting the player. The actual launch position is looking at the enemy target as it is cycling around the player. And so that is going to be, when we come back to our robot stick controller, the bullet transform is getting attached to the launch positions rotations, which we have now set to be looking at the enemy target. So we looks like it's just looking at the player and it will hit you. It's going to be shooting toward the player, but may or may not hit. Okay. And so this is going to be running every frame. Every frame is going to see if it's okay to shoot. If it is okay to shoot and the player is still within distance, right, it's going to shoot, and that is going to be controlled because we're going to move between true and false between our shooting pulses. Okay. What we're going to do, let's have one more bit of fun. We're going to come and open up our bullet collider, right? So all of our bullets have this. And we're returning them to the pool. We return to the pool after 5 seconds. What we're going to do, actually, let's handle this in the pool. So bullet pool, right? So if you remember, when we return it to the pool, we set its velocity to 0 so that it's not moving and it doesn't have any velocity attached to it while it's not activated. What we're also going to do is we're going to object to, hold on, it's been a hot minute since I've looked at this, so let's go real quick back in here. We're going to, in our prefabs is where our bullet is. Our bullet material is the red, right? Yep, so we've got our red bullets on here. Oh, that is my phone, hold on. Okay, what we're going to do is we're going to, so it's set to red, right? So that's what the player is shooting. What we're going to do is, in our bullet pool script, we're going to add serialized field, oops, not a game object, material, we'll go red and blue. No, we just need red. And so what we're going to do is, when it comes back, we're going to make sure that the object do deactivate, object to deactivate dot get component render material red. We're going to make sure that we set it back to red, because what we're going to do is, when the robot fires its weapon in our controller, we're going to say bullet get component render dot material equals blue. Right, we've already set up our blue here, and so this is going to allow us, it should, when it fires, it should change the bullet to blue, which is the color of the blue attacking laser, and then it's going to put it back to red when it's done. Once again, this is just ways to continue to reuse different parts of the code. Okay, bullet pool, perfect. So what we just need to do is, in our bullet pool, we will go back here to our game controller. Bullet pool now has a spot for red, so we will add in our bullet to the material because our red bullet is red. Okay. Whew, that was a bunch. Let's go ahead and see how this is. So we're going to hit play. We've got ours moving around. It's coming up to us. Up. We are in blue. We moved far enough away. Alright, it is not shooting at us. And for some reason, we're not shooting very straight all the time. Awkward, we'll deal with that in a bit. Oh, I didn't assign the launch position. That would do it. Fabulous when you have these. As you can see here, its variable was not been assigned, so that means I forgot to do it. In our robot, we need to scroll down. Bullet is fine, it doesn't need to be there. Our launch position is what we need, which is our laser launcher. Okay, we'll hit save. Now we'll hit play again. We're going to try. Oop, he turned green. I see you. Now he's going to go blue. And he's just wrecking us with that bullet. It's going really fast. Too fast. Okay. But you can see that it is looking at us, it's staring, and then if we go far enough away, it goes back to red and goes back to its jump, and then it will eventually do everything, switching between its states just like we want it to be. Okay. Awesome. So we've got our state set up, which is great. We have this new attacking state. Let's go ahead and we're going to go ahead and we're going to lower the speed of the bullet that the robot's shooting, because that's crazy. So we can close our bullet pool now because that's fine. The collider, we're gonna play with in a minute. And so in our controller, we're going to say that it's really only gonna fire at, let's say 10. So I want to see, let's do 5. I want to see where it's actually going. I have this sneaking suspicion that it's firing straight up. So let's check that real quick. I'm going to make you attack me. And it is. Okay. So let's go ahead real quick. apparently this needs to be, there's not always an always for this, so a lot of it is trial and error to a degree. So we're going to try forward and see if that now fires directly at the player. So we'll change that to forward. Come back here. There we go. And as you see, it is firing at the target, which is constantly moving around. And as it does, sometimes it's going to hit us, and sometimes it's going to hit. Okay. Now you're just starting to bother me. Most of the time it's aiming at it. We'll get into fine tuning in a little bit. This is mostly just making sure that everything is working mostly okay. We'll dial in those probably in the next video, because this one's already getting pretty darn long. There is one more thing that I want to make sure that we are covering in this before I have this be the end of this video. Once again, like I said, we're getting a little long on this one. And that is collisions. And so if we hit play, at some point maybe I want to make it where I can shoot the robot, right? If I can shoot correctly. Awkward. Not sure why that's going there. Anyway, so with this, it's driving me nuts. Okay, we're going to deal with that later. But we want to, it's a game. We want to make it so if we shoot the robot, it's going to destroy the robot, or it's going to take a certain number of hit points, right? And so let's play with this a little bit. So what we're going to want for a collision to happen, something needs to have a rigid body attached to it for it to actually collide, and it needs to have a collider, right? So if we pull up our prefab of our bullet, we've got a rigid body on it. And so that is what we want to make sure that it's actually hitting something. And so now if we have that, what we can do in our script for our bullet collider, right? We've got bullet's gonna disappear after 5 seconds no matter what. But we have this on collision enter. And so that's going to tell us what we're colliding with. And in any case, if it collides with something, it's going to go back to the bullet pool, right? But sometimes we're going to care what's being hit. And so what we can do is we're going to just debug this. Oops. Log collision dot collider, because we need to know what is being collided with, dot game object dot name. So we're going to get the name of the game object and have that report when we shoot. So we're going to, with this, now hit play. I'm going to open up my console here. And so when I shoot and I hit the robot, it says I hit the robot. If I shoot and hit the wall, it says I hit the wall, right? I'm aiming at the robot, and sometimes it hits the wall. Um, but right, so we're hitting the robot when we hit the robot. So that's cool, but let's look at, hold on, let me go back here, and I'm gonna go to my prefab of my bullet, and on the rigid body we have collision detections, and there are 4 different versions here: discrete, continuous, continuous dynamic, and continuous speculative. So we're going to set this back to discrete for a minute to show where this affects things. So we're going to do discrete, and then we're going to go in to our player controller code where we shoot the bullet, right? And we're going to crank this up to, I think 500 will work. So if we increase our speed of our bullet to 500, I think, hold on, let me real quick. Sorry, I think I just figured out why we're having some bullet direction issues. Let me see if that is what is going on. Scripts, bullet pool. So I think what's going on is the same thing as we've removing our angular velocity. I think it's having it's keeping part of its rotation on. So I'm gonna just try this. Object to deactivate dot transform. Yeah, transform. And we're gonna do an local Euler angles equals new vector 3. Set it to zeros. That should hopefully be what was causing the problem? Question mark? We're going to find out here in a minute. Okay, so with, we're just going to, it might be too fast. We're going to see. We're going to figure this out. And so if we hit play now, we're going to go back to our console. It's even saying where it's hitting, floor, floor. It hit me, it hit the player, right? I'm going to shoot. We see how fast that's going now. I mean, that's really hard to see, right? I think I fixed it. It's not shooting all over the place. Yes! But if I shoot at, I'm going to move far enough away so it's no longer hitting me. I'm going to clear this. And I'm going to shoot the robot. But it's not, it's hitting it, right? We can see it going through, hit a wall. But even the wall isn't a guarantee that it's hitting it, right? Like, I can finally get it to hit if I get just in the right spot, but if I move a little bit, it's no longer hitting it. And what is going on is, let's pause this. I'm just going to bring a sphere in to just kind of show what's happening here. So what's going on here is it is moving. So our bullets are moving what appears to be in one just continuous line, right? But what's actually happening is it's moving a certain distance every frame. So frame 1 could be here or it could be here. frame 2 could be here, frame 3 could be here on that update loop, right? And so unless the frame happens right as that is making collision, it's never going to register as a hit. And so discrete, let's go back to our bullet. In our collision detection, no, it doesn't give you the full definition. Or does it if I hover it over this way? Of course not. Let me just look it up so I make sure. Collision detection types. All right, so discrete, which we had it set to, right, is used for slow moving collisions. So if this, and so the reason why when it was shooting at 5, right, it kept hitting me, it was moving slow enough that for the most part it was going to hit. So it was a slow moving collision, not a problem, right? And so if you're moving at any speed beyond just a snail's pace, not that 5 is snail's pace, but it's definitely a lot, right? We are going to have moments, if it's on discrete, where it is jumping through the target and it's not even making collision. So that's where our other ones come into play. So continuous is really meant for fast moving linear collisions, right? So you're in a straight line, and usually are going to be used for stuff that's a high degree of accuracy, right? Which a bullet would be in this case. And so beyond that, you've got continuous dynamic and continuous speculative. And this gets really crazy into all the other things that are going on. Continuous dynamic is really, it's once again for fast moving, still linear collisions, but it really comes into the dynamics of physical bodies that are colliding with other moving colliders, right? We don't need to go this way. The higher up we go, the more computing power is required for it. Something small like this is not going to have a big issue or impact, but other things it definitely would. Speculative, once again, is also for fast moving collisions, but it doesn't have the degree of accuracy as dynamic or continuous. And so usually we can get away with just continuous. And so if we switch to continuous, we hit save, and we go back, oops, I need to remove that, hold on. Because now we just have a floating ball in the middle of the field. We're going to get rid of that real quick. And so now it's checking in a different way from how discrete was, right? And so now if I come over here and I shoot, let's get our console open, and I make sure I'm hitting. Now I'm hitting the robot pretty much no matter what. This is still a lot of speed, so with this we may actually need to go all the way up to dynamic. You're going to have to play with and dial it in to see exactly what you need it to be. But if we, let's test that. Bullet, continuous dynamic. save it, play it, because we still had a little bit that was popping through. Oops, let's bring up our console. And now I might still be shooting through. I am. Well, let's try. Let's just give speculative a try. Alright. Oops, let's get our console open. Let's clear it. It is hitting everything, I think. It's thinking it can hit every single thing, so that's not doing it for us either. And so our most accurate was our speculative, or just our continuous. And so what we can just do with this is drop this. Right, 500 is ridiculous. If you're getting it up to that level of speed, really you just want to switch to a raycast, right? You aren't really using this in the ways that it was meant to be for an object that's moving. If you're moving that fast, you might as well just have a raycast that just sends and says, hey, I'm pointing in this direction. Do I hit? What do I hit? Is it, you know, the enemy? Great. If not, great. So we can set this though to 100, which is still pretty fast, and we should not have a problem. And now still having a bit of an aiming issue. I'm gonna have to look a little bit more into that. It's going wherever it wants to go. But you can see where it is. We'll play more with dialing that in a bit. Okay. 100 is more than I want. I'm going to set this to like a good 30. Still want to be able to see it. But we've got, once again, as before, now it's still going to be too fast for discrete. We want that continuous collision detection. Okay, let's handle the last bit of this. If the bullet, so we now can see our name of the thing that's colliding with. So if collision dot collider dot game object dot name equals robot. We want, let's not, because it's going to be where we're going to create a tag here. Actually, we're going to add a tag so we can track this through tag. We're going to call it robot, and we're going to come back and we're going to switch this tag to robot, and we're going to tag all of them so that just in case, no matter what you hit, it is hitting the robot. You're not going to hit the laser launcher. So then if, instead of name, we're going to check tag is robot. Destroy collision collider GIMM object. And then, no matter what, we're returning the bullet to the pool. So now, if we hit play, and we just say, hey buddy, you think you're sleeping. I want you to get back to work so bad, I'm going to destroy you. Boom. It disappears. All right. That is a lot. And so I'm going to call it here. I need to look a little bit more into why it is still having an issue with that rotation and firing off into some little different directions, but that will be for a different video. This has covered a lot of different aspects and made some changes to the game that we've been building through this in class. So hopefully this is helpful through many of your other games, especially if nothing else, understanding a little bit more of the collision detection modes, which is really helpful, and definitely needing to know whether you're, for the most part, needing to know whether you're using discrete or continuous, or if exploring speculative or dynamic is in your best interest. So I'm going to call here. I'll see you in the next video.